Hello and welcome to week 9 review for AP Environmental Science. This week's topics are age structure diagrams, total fertility rate, human population dynamics, and the demographic transition. So for most of human history, the human population overall had a really slow rate of growth. So when we look at this graph with the human population from about 1 AD to 2050, we can see here that the population doesn't even reach 500 million in number. But then all of a sudden, at around 1800, we see this huge spike in the growth rate. And if you remember from last week, this is a J-shaped curve. This is a type of growth curve that we would classify as exponential growth. So from what you can remember from last week, what are some possible reasons why this happened? Usually when we see an exponential growth curve, it's because the population has infinite resources, or there's a lot of space, or it's a newly disturbed territory and they have access to as many resources as they need. So the current world population now is about 7.8 billion. What accounts for this rapid phase of growth that we've experienced within the last 200 years? Number one, we've been able to expand into almost every habitat on Earth. So our population is not limited by space. We also have modern agriculture, which allows us to have a high productivity of food in a small amount of space. So we have plenty of food to feed most people. And we've also been able to greatly reduce our death rates through medical advances, increased sanitation, and more broadly accessed healthcare. So essentially, we've been able to outmaneuver that environmental resistance that normally causes population growth to show that logistic curve. Now, this growth is also not equally distributed. So if you look at this map here, you've got some darkly colored orange spaces. That is where population density is the greatest. So here in India, China, Europe, and then some places in America, that's where most of the people are. This also means that the growth rate in these areas is also highest because there's most people in these spaces. So at least 95% of the 2.7 billion people that are likely to be added to the world's population by 2050 will be in these countries that are less developed, like India and China and elsewhere. So what does this mean for both the human population and for the environment? So as we've already kind of talked about previously with the human impact on the environment, overpopulation is one of these things. We oftentimes will destroy habitat or greatly disturb it in order to build larger houses or farm land. We also can see in what we're going through right now with the pandemic that high population density areas increase the spread of these diseases. We know that disease in general is a density dependent factor. So number one, why is this an environmental issue? Because it's really just about human population. It's mostly about natural capital degradation. So one of the hugest impacts that we have is the overall reduction of biodiversity. Just like we talked about in Unit 2, humans have almost led us into this extinction crisis, the sixth extinction, where the amount of our population as it grows, the impact that we have on habitat loss, overharvesting, the spread of invasive species are causing extinction rates to also increase. We also have some other impacts that are directly related to our population as well. We increasingly use more of the net primary productivity that is worldwide produced. We are increasing the genetic resistance in pest species and disease-causing bacteria. Oftentimes, when we move into areas, we eliminate the natural predators that are there that compete with us. We're typically using more of our renewable resources that can be naturally replenished. We also disrupt those biogeochemical cycles we talked about previously. And almost most importantly, a lot of our growth is fueled by the use of fossil fuels. So when we think about our population growth, we also have to think about our impact. Those are also related to affluence levels and technology use. So as our population increases, and also as we start to use more resources per person, our impact is magnified. So before we get more into the dynamics of the human population, let's review some of the population math basics that you'll need to know for the AP exam. So remember that population change, or population change in rate, can be calculated by looking at the amount that are incoming, so births and immigration, and then you take away those outgoing from the population from deaths and immigration. We can look at the crude birth rate, which is the number of live births per 1,000 people, or births per capita in a population in a given year, and also the crude death rate, which is the same just for the number of deaths. We can calculate the crude birth rate by taking the number of births per year per capita of the total population and multiply that by 1,000. Same thing for the crude death rate. Annual population change is when we take that crude birth rate and subtract the crude death rate and multiply that by 1,000. So if the crude birth rate is 0.01 and the crude death rate is 0.02 for a population of 1,000 people, that means that 10 people will be lost from the population each year. Another way that we can think about this is that the rate of change, the population growth rate, is equal to the birth rate minus the death rate. So let's look at an example problem here. New Fremont had a birth rate of 12 per 1,000 in 2010 and a death rate of 9 per 1,000. So remember that population growth rate is CBR minus CDR over 10. So we've got 12 minus 9. We divide that by 10. So 3 divided by 10, that's 0.3% growth rate. One of the most important types of math that you will need to do with the human population is the rule of 70. So when we think about the change of human population, it's instantaneous. People don't just reproduce once per year. So when we think about if we're adding this many people per year, how many more will be added at any given time. So in order to do that easily for apes, we use this kind of quick rule of 70, and it's based off of the natural logarithm. So to find the time that it would take for a population to double, you're going to divide 70 by the percent change given to you in a problem. So here's a sample. The small town of West Fremont has a population of 50,000. If the growth rate of West Fremont is 2%, then how long will it take for the population of West Fremont to double? So doubling time, 70 divided by the rate. So the rate is 2%, 70 divided by 2. It would take 35 years for this population to double. I'll be giving some other samples later so that you can better learn how to apply this particular rule. If the population of a country grows at a rate of approximately 5% per year, the number of years required for the population to double is 14 years. Now, this is a problem where you have to apply the rule of 70. So how do I know that it's going to take 14 years for this country's population to double? So remember the rule of 70, 70 divided by the rate, that equals doubling time. So here they give me the percent. So 70 divided by 5, that is 14 years. Our country currently has a population of 100 million and an annual growth rate of 3.5%. If the growth rate remains constant, what will be the population of this country in 40 years? So the answer here is 400 million. But how was I able to calculate that without having to use a really complicated math formula? Well, here we're given the time period that we need to consider the growth in. We have the original starting population as well as the growth rate. So we can use the rule of 70 here in a little bit of a different way. So 70 divided by 3.5, that gives me 20 years. So this population at this percent of growth will double every 20 years. I know that I'm supposed to be considering this in 40 years. So how many times does 20 go into 40? That gives me 2 times that the population will double. So I know the starting point here is 100 million. So in the first doubling, it goes from 100 million to 200 million. And then in the second doubling, it goes from 200 million to 400 million. Seemed like a very complicated problem, but once you apply the rule of 70, they're usually pretty straightforward. So let's kind of zone in on one and its historical change in growth rate. So this is the United States population between 1900 and 2010. As you can see, the growth rate has not been the same throughout this entire time span. Sometimes it's higher, sometimes it's lower, and then it kind of levels out towards the end. So let's take a look at what's actually happening in the world or in the United States that might have contributed to this plummeting growth rate that we see. What might have happened straight afterwards? What happened here and here? These are all types of questions that you may ask. What type of cultural, economic, and environmental things may be going on that are affecting this growth rate? Basically, what caused this trend? So if you've maybe taken a lot of history classes, you may know that around this time, 1917, 1919, we're having a world war. There's also the Spanish flu. And so many people are being lost out of the population. Here in the 30s, that was the Great Depression. Again, a time of economic unease and resource depletion. So we have a drop off in our growth rate as well. Here, this is the post-war boom that added a lot of babies and children to our population, and then steadily it leveled out to about 1%. So let's talk about one particular feature of population growth that demographers look at to be able to predict a lot about a country's standard of living and also population growth in the future. And that is something called TFR, or total fertility rate. So this is the estimate of the average number of children a woman will have during childbearing years. Typically, this is done between 15 and 44 years of age. Now, that doesn't mean that there aren't people that are younger or older than this having children, but just from a demographer's criteria, this is the age range that we're looking at. So when we look at the past years, about 100 years here with its predicted TFR in the future, 1950 to 2050, we see that total fertility rate historically has been much higher than it is today. So this blue line here, that shows total world TFR. We can see that it's been on the steady decline and it's leveling out to about 2. Here in Africa, it's been very high for a long time, and again, it is leveling out. In more developed regions, it has also began to decrease and is leveling out too. And you notice it's kind of remaining at about 2 children per woman during the entire reproductive period of her lifetime. So why are we seeing this trend in dropping total fertility rate? There are many, many reasons. First, we need to consider all the different factors that can affect birth rates and total fertility. So I'm going to be showing you some factors, and I'm going to show you from what type of change will either increase or decrease the birth rate. So let's look at children as part of the workforce. Now, in our modern society, especially in very developed countries, rarely do we see a large proportion of children employed in the workforce. But that hasn't been the case historically, and it's not the case around the world. Now, as more children are needed as part of the workforce, that does tend to increase birth rates. Families need children in order to provide for the security of the entire family. As this becomes less of a necessity in a country, then that tends to decrease birth rates. Not as many children are needed. Also, the cost of raising and education of children can affect things. When it is very low, then it's more economically easy to have more children. And when it is very high, that might be a consideration to people and their fertility. Also, the availability of pension plans. So when we talk about pension plans, we're talking about when people get older, they're able to retire and they still receive some type of income and do not have to yet work. We see in countries where there is a steady availability of these plans that decreases the birth rate, mostly because people do not need to insure their older years to having children to take care of them. So in places where those are widely unavailable, that tends to increase birth rates. Infant death rate is probably the #1 predictor of high birth rates and high total fertility. When infant death rates are very high, families tend to have more children. I don't want to say it's more like an insurance policy, but it kind of is. So infant death rate is also going to be very important when we talk about quality of life. If families are safe in the knowledge that their children will live to see adulthood, they tend to have less. If that is an uncertain thing, they tend to have more. Urbanization can also play a role. So are people living in cities or are they more concentrated in rural areas? So people that are in larger cities tend to have access to better healthcare and family planning. So if you have low levels of urbanization, that is correlated with an increase. But if people are living in cities, that actually decreases their birth rate. Also, a very important aspect of some of the things we'll talk about later are women's educational and employment opportunities. Typically, if women have a lot of ability to go to school and they have job options, that tends to decrease the amount of children that she will have over time. It also delays the onset of reproduction as well. Average age of marriage, if people tend to be waiting to get married, they tend to have less children. And if they are getting married early, they also tend to have more. And finally, the availability of legal abortion and reliable birth control. So family planning resources are really important for people to be able to control their own fertility. So when those are widely available, that tends to decrease the birth rate. And if those aren't, it tends to increase them. Also to consider cultural and societal and religious beliefs and norms. Some cultures and religious value large families, or they may restrict access to family planning. That tends to increase birth rates. If the cultural norms value smaller families, or if there's a wide access to family planning with no restrictions, then people tend to have less children. So let's take a look at the historical patterns of total fertility rate in the United States. This should look very similar to the other graph that I showed you about growth rate. So we saw a huge drop off in our growth rate during the Great Depression. So TFR went from about 3.4 children per woman all the way almost to replacement level, which is 2 children per woman. What could be some of the reasons? Decreased access to resource, unemployment, people in general living in an economically unstable time don't tend to want to have more children at that one time. Another time that we see the TFR in the United States drop off is during the 1970s energy crisis. Again, economic instability, possibly people are worried about not having employment, or prices are getting higher, so it's more expensive to pay for children. And then again, we see a little bit of recovery and then a dip at the Great Recession, which just happened a few years ago. So again, people might have been losing their homes, losing their jobs, and that doesn't typically correlate with higher birth rates. So most of the growth that we see in populations are also to do with death rates. As we see from our first graph of that exponential growth, a good deal of our growth around the world has been our decrease in death rates, not necessarily an increase in birth rates. So what are the factors? Food supply is huge here. As we modernized our agriculture, we have genetically modified crops, we have access to fertilizers, pesticides. We've been able to keep malnutrition at lower rates, and more people have access to food. That tends to decrease the death rate. So when food supplies are readily available, less people die from resource-related deaths. Also, access to vaccines, antibiotics, and other type of life-saving treatment, that decreases our death rate as well. And we are consistently getting better and better at these things, and it's becoming more widely available to more and more people. Sanitation and safe drinking water is also really important. And most of the deaths that occur to children under 5 are actually because of sanitation and drinking water issues. So as those systems become better, the infant mortality rate also declines. So infant death rate, that's informed by all of the above factors. So generally when infant death rates are high, that's going to increase death rates, and then when they're low, that helps. So worldwide, we can see a shift in what is actually causing the most deaths. So we used to have a large proportion from communicable, meaning viruses, bacterial infections that you can catch from other people, or nutritional diseases like malnutrition or lacking a specific nutrient. And we also see that as we've decreased the communicable and maternal and nutritional diseases, most deaths now are caused by non-communicable diseases. This is things like heart disease, cancer, diabetes, and respiratory chronic illnesses. So another way that we can look at the human population and use its demographic statistics to predict quality of life and also potential growth rate is by looking at age structure diagrams. So do expect to see some of these on the test. So an age structure is just the proportion of each population for each sex at each age level. So this is a diagram of the United States in 2018, and you can see that for children 0 to 4, males made up about 10 million, and females made up about a little less than that, maybe 9.5. And then you can see at the top of the pyramid here, the older cohorts are making up the least amount of individuals. You can also see this very interesting trend of these two bulges, and we're kind of going to talk about what those bulges mean for our population and for some other economic concerns. So in general, we want to look at 3 categories. The individuals that are pre-reproductive, so that's 0 to 14, reproductive, 15 to 44, and then post-reproductive and up. So what you will need to be able to do with these age diagrams, these age structure pyramids, is predict what the growth rate is based on the shape of the pyramid. In general, if you see age structure diagram that does have this really kind of nice pyramidal shape, or it looks like a triangle, that is associated with rapid growth. And the reason why is because the number of individuals that are young far outweigh other individuals in the pyramid, meaning that as these individuals reproduce, they will have even more. And then those, when they get into their reproductive years, will have even more. And the population will just keep ballooning. Now, slow growth is still kind of this pyramid shape, but it's less severe. So there is an increase in individuals, but it's just not as rapid. You usually see these in developed countries where there's also some good rates of immigration. A zero growth pyramid is going to look more like a column. So in all growth pyramids, there's a tapering at the top because those are our oldest cohorts and they experience the most deaths in their cohort. But if you can notice what's happening with the reproductive and the pre-reproductive cohorts, they're about even. This means that they are likely at replacement level fertility. And that is about 2.1 children per woman. Now, how do you have 0.1 of a child? You don't, but there needs to be slightly more than 2 because you do still have some child and infant mortality that occurs. Now, we've looked at sort of like the growing populations and then the ones that are able to maintain a certain number and not grow or decline. But there are some countries that are experiencing negative growth. These tend to be developed countries that are have maybe more restrictions on immigration, and they are seeing a decline. Their TFR has dropped below replacement level 2.1. So here we know, we can see this because it's got this bulge in the middle and it tapers down at the bottom and at the top. Now, what's typically good about negative growth and even zero growth countries is that you can see the life expectancy of their population is very high. People tend to enjoy a high quality of life. They have access to medical care and plenty of food and other resources. So they live a long time. That means then that they tend to have less children than in other countries that are experiencing other type of economic situations. So with this, it's important to also look within each country or economic system at the dependency ratio. That's the number of people below 15 and above 65 who are generally dependent on the remainder of the population for their support. So they're currently not contributing to the economy. This would be small children, school-age children, and then retired and elderly individuals. So they are potentially going to contribute, or they have for the rest of their life, they just aren't doing it at the moment. If the dependency ratio is higher or it's increasing greater than the people that can support them, then there can be some negative outcomes. And we're going to talk a little bit about how that might be happening in the United States. So normally we associate negative outcomes with high growth rates in countries. So if a population has a high growth rate, it's probably because maybe they don't have educational opportunities for women, or there's not enough medical care, or they need children to work. But there are also consequences when countries begin to see declining growth rates. And right now, we might be facing one of these particular consequences. So as you've seen before, there was a post-World War II baby boom where our growth rate increased and our TFR increased. So at around 1985, these individuals that were born at that time started to reach their reproductive years here. So in proportion to all other cohorts, they were the most numerous. Now, in 2000, these individuals were or the oldest of their generation, were starting to enter into the post-reproductive phase, but they were still working and weren't part of that dependency ratio. However, now these individuals are mostly starting to retire. They're mostly starting to take advantage of our Social Security and retirement benefits, so that after their long life of working hard, they're now enjoying their older years. The problem here is that our Social Security system and a lot of our other benefits are based on that dependency ratio. So as a large percentage of our population move into depending on the workers below them, there may not be enough to actually support the systems. So let's take a look at how many workers are needed to support one Social Security retiree. So in 1945, there were over 40 workers per retiree that helped to support those benefits. But as you see, as our growth rates have declined and our TFR has declined, this has become less and less. So if this drops below 2, that means there may not be enough workers to support our retirement systems and our Social Security, which is something that we've all sort of grown to rely on in our older years. So why exactly is this occurring in more developed countries like the United States, where you had this rapid population increase and then you have a decline? So what is generally occurring in most countries is something called the demographic transition. And if there was any diagram or figure from this lecture that you want to remember, it is this one, because it's always on the test. So at stage 1, which is in a pre-industrial stage, this is before modern agriculture or large industries, big fossil fuel use. It's mostly dependent on human labor. You see that there are usually high birth rates, but there's also high death rates, because there's not access to medicine, vaccines, and other types of things we know increase or decrease our death rate. So even though both are high, they're about equal. So growth rate tends to be pretty low. However, as countries start to modernize, as agricultural practices get better, more medicine is available, we start to see a huge decline in the death rate. Infants are getting vaccines so they don't get sick. People have access to more nutritionally dense food and more resources in general. So at first, the birth rate does not change at all. It stays the same. There's this reproductive lag time, but death rates decline. And this is when we start to see that exponential growth occur. Because death rates are declining, but birth rates are staying high, the total population really expands quickly. So in the industrial phase, which is what the United States was kind of doing around mid-1800s up until about 1950 or so, we can see that now that we're used to this low death rate, we also tend to have a declining birth rate, more access to medicine, more educational opportunities for women, delay of marriage and building families because people are investing in their education, they're investing in the workforce. Then we start to see the birth rate decline. But we've already added enough people to the population that growth rate doesn't really slow yet. That only happens in the post-industrial phase. So some of these older developed countries like Germany, Sweden, Japan especially, they are seeing their growth rates actually go negative, and it's because death rates have stabilized to their lowest amount, and now those birth rates are starting to decline as well. So the demographic transition is really important to consider for planning for the future, for government intervention in how to support a country that is having a ballooning population, but also a declining one at the same time. So please make sure that you are studying this diagram of the demographic transition. All right, let's get into some practice questions. Which of the following is most typically associated with the transition from a rural to an urbanized society? Reduced birth rates, reduced need for sewage treatment facilities, increased rates of population growth, increased air quality in urban areas. So this was one of the things that I mentioned earlier that was a factor in declining birth rates and also declining death rates. So the answer here is reduced birth rates. Now let's take a look at the other ones. We knew it wasn't C because we know that once countries urbanize, once people move into urban centers, population growth tends to decrease. But it would also be true that once you increase population density in these areas, these problems would actually get worse. You probably are going to see a decrease in air quality, and there will be more need for dealing with human waste through sewage treatment because you have a high density of humans living together. The current global human population is about 6.1 billion and is growing at an annual rate of 1.35%. If world population were to grow at this rate for the next year, approximately how many people would be added? So this is one of the math questions that we practiced earlier. So we know we've got a human population of 6.1 billion. That's 6.1 times 10 to the 9 people. We also know that we have an annual growth rate of 1.5%. Now, this isn't a rule of 70 problem because we are just wanting to know how many people would be added the next year. And we are given the annual growth rate. So we just need to multiply this by the growth rate, which would be 1.35 times 10 to the negative 2, because this rate is actually 0.0135. So we know from our discussion on using scientific notation that this is going to give us 8 times 10 to the 7, because 9 minus 2 is 7. And that is the correct answer. Factors that affect the total fertility rate of a human population include which of the following? Cultural traditions, government policies and economic incentives, educational level, and economic opportunities for females. So we're just looking at factors that affect the total fertility rate. Could make it go up, could make it go down. So let's consider those cultural traditions. If you have culturally high value for large families, people would have more children. If there are restrictions to family planning, people might have more children. So cultural traditions are definitely a factor. Also, government policies and economic incentives, and educational level and economic opportunities for females. We know as this goes up, our TFR tends to go down. So all three of those are definitely going to affect TFR. During which stage of the demographic transition shown above does a population begin to experience an explosive increase in growth? So if you were able to remember that entire figure, you would know that our growth curve does this, and then it kind of tapers off, right? And that's because you have this gap between a steady high birth rate, but then a rapidly declining death rate. So this would definitely be during stage 2. That's when it starts. Which of the following is most likely the primary cause of high death rates in phase 1? So remember, phase one, that's that pre-transitional state within the country. So you've got high birth rates and you've also got high death rates. So why is this occurring? Probably not going to be due to males in warfare. Number one, remember, we typically quantify our growth rates and our fertility rates to females, not necessarily males. Although this is probably the case, we still have enough females for us to have a high birth rate, so that's probably not the case. If you have high death rates and high birth rates, you're probably not having as many elderly individuals in your population as you could. So typically we see the high death rates due to infant and childhood mortality. Again, that's due to possible diseases from lack of sanitation and communicable diseases that can be vaccinated against, like the measles. Which of the following characteristics is most closely associated with a country that demonstrates the age structure in the diagram shown above? If you remember the 4 different types of pyramids that I showed you before, we know that pyramids that have a large base, that have that really like tapering effect at the top here, those tend to have high death rates. And if it's occurring here at this level, it's because there is a high infant mortality rate. So if the population has access to medical care, that actually causes the pyramid to do this, either be slow growth or no growth, or even to decline in growth and have that bulge in the middle. If there's low population growth rate, again, that's going to be these. And if there's low total fertility rate, that's also going to be those slow, no growth or zero or negative growth pyramids. So let's practice with a free response. So the graph below shows the demographic transition of a country called Industria. In 1855, Industria had a population of 1.6 million with a crude birth rate of 43 per 1,000. At that time, the population was growing slowly because it had a high death rate of 41 per 1,000. In 1875, the population began to grow rapidly as the birth rate remained at its 1855 level, while the crude death rate dropped to 20 per 1,000. And we can see that here. Death rates dropped really far, and then it took a little bit longer for the birth rates to level out. In 1895, the crude birth rate dropped to 37 and the death rate to 12 per 1,000. And in that year, a census revealed that the population had grown to 2.5 million. By 1950, population growth declined as the death rate remained at its 1895 level, while the birth rate continued to decline to 22 per 1,000. In 1977, it was revealed that the death rate was 10 per 1,000 and that the population growth slowed even more to an annual rate of 0.4%. By 1990, Industria had reduced its birth rate to that of its now constant low death rate, and the demographic transition was complete. So they are in that post-industrial phase. So they want us to calculate the annual growth rate of Industria in 1950 and calculate the birth rate in Industria in 1977. Also, we need to calculate the population size of Industria in 1951 if the population had continued to grow at that annual rate recorded in 1895. So let's take a look at A first. What was the annual growth rate of Industria in 1950? So I need to look back through this paragraph here and identify what numbers I need to use. So here it says, by 1950, population growth began to decline as death rate remained at its 1895 level. Well, in 1895, it was 12 per 1,000. Now the birth rate then was 22 per 1,000. So now I have my numbers I need, but how do I calculate it? So remember, we can calculate growth rate by taking the birth rate and subtracting the death rate. So births were 22 per 1,000. Deaths were 12 per 1,000. So 22 minus 12, that is 10 over 1,000. And it asks me for the rate. So I'm going to convert that into a percentage, which is 1%. 10 is 1% of 1,000. So in 1950, the growth rate was 1%. But now I need to calculate the birth rate in 1977. So let's erase this. Let's remember what our formula is. Rate equals births minus deaths. What about in 1977? So I know that vital statistics revealed the death rate was 10 per 1,000, and that I know the overall growth rate was 0.4%. So that is 0.4, that's the rate. I know that I'm trying to determine the birth rate, okay? But I do know my death rate. My death rate was 1%, which is 10 over 1,000. So I just kind of solve my little problem here. I add 1 to this side. So 1.4 is the birth rate, 1.4% in 1977. So a lot of words to have to go through. They give you a lot of info and a lot of numbers, but if you can just locate what you need throughout the paragraph, the math is actually really, really simple. And if you get a problem on the test that has to do with population growth, please do try to attempt it. All right, so let's look at the second part. Calculate the population size of Industria in 1951 if the population had continued to grow at the annual rate of growth recorded in 1895. So again, looking back in that paragraph, I know that in 1895, the crude birth rate dropped to 37 and the death rate dropped to 12 in 1,000. And in 1950, the population had remained at its 1895 level, which was 2.5 million. So I think I've got all of the information that I need to calculate population size. This one's a little bit more complicated though. Let's start off first though by calculating our rate. Rate is births minus deaths. So I know I had 37 out of 1,000 being born, 12 out of 1,000 as the deaths. That is 25 over 1,000. And that gives me a growth rate of 2.5%. So now I've got some of the information that I need to know to be able to calculate population size, because I needed to know the growth rate first. So that's 2.5%. Now we're talking about a pretty large jump in time, 1895 to 1951. And all I can know is that at any given time in this period, that the growth rate is happening at 2.5%. This is instantaneous. So I'm going to need to use the rule of 70 to be able to solve the rest of this. So let's remember what the rule of 70 is. That's 70 divided by the rate. Well, I did calculate my rate. So let's go ahead and see what doubling time is. So 70 divided by 2.5, that gives me 28 years. So I know that if this population stays at a growth rate of 2.5, it will double every 28 years. But what is the time period that this is occurring between? Well, going from 1951 to 1895, that is a period of 56 years. So how many doubling times are in 56. So 56 years divided by 28 years, that gives me 2 doubling times. So I've almost got everything that I need to do this problem. So let me make a little bit of room and we'll finish up, because we still need to know the size of Industria in 1951 if it stayed at that same rate. So in 1950, we know that there was 2.5 million. So that's 2.5 times 10 to the 6. It doubles once, right? So that's going to be 5 times 10 to the 6. And then it doubles again. So that was 1 doubling time, and now I'm in my second. It's 10 times 10 to the 6. Now we can't leave it that way because that's not in the most reduced form here. So that is 1.0 times 10 to the 7. That's going to be the population size of Industria in 1951 if it had continued to grow at the rate that was recorded in 1895. All right, let's kind of shift gears here and talk about demographic data for another country more recently. So the table below contains data for Haiti in 1995 and 2015. So we know the fertility rate here has dropped, the life expectancy has increased, and infant mortality deaths has also dropped almost by half. So all of these demographic indicators tell us that the quality of life is increasing in this country, that they are going through the demographic transition and are getting into the industrial and post-industrial phases. So A wants you to identify and explain how one factor in a less developed country that could contribute significantly to a change in life expectancy, similar to what occurred in Haiti from 1995 to 2015. And you have to do the same thing for an economic or cultural factor that could have contributed significantly to a change in the fertility rate, similar to what occurred in Haiti in this time period. So let's look at A first. Identify and explain. You would have gotten 2 points here. 1 point for correctly identifying a factor that increases the life expectancy, and then 1 point for explaining how that actually happens. So these are all of the things that we previously talked about. When you have an increase in access to healthcare, fewer deaths end up happening from treatable diseases, those communicable diseases. You also are able to decrease the infant mortality rate because vaccines keep the younger children from getting things like measles. You also can do the same thing by improving food quality or quantity. Better health and just general access to food and nutritionally dense food ends up reducing your deaths from malnutrition, and that means that your death rate is decreasing. That also decreases diseases that are foodborne. Sanitation, sewage treatment, and clean drinking water. That is key to reducing infant mortality rates, so you have fewer waterborne and communicable diseases. If women are having fewer pregnancies, then that actually decreases the amount of possible maternal deaths, and again, increase in health-related education that kind of goes along with our clean water and sanitation that reduces disease transmission. So one thing to keep in mind here that's really important for getting full points on a portion of the free response like this is to do both things that they are asking you for. So it's not enough here to just have identified one of the factors. You also need to understand and be able to describe how that actually works. And if you look back in this presentation and look at that, those 2 tables, that will really help you. All right, so let's look at what happened to change the the economic and the cultural factor that decrease fertility rate. So be careful here again, this has to be economic or it has to be cultural. And you get 1 point for the factor and then 1 point for the explanation. In general, if there's anything that you can remember that helps to reduce TFR, it is going to be these top two. I would say if you can just remember that, that will always be applicable to a question like this. If you increase education for women and more economic or job or work opportunities, women tend to have fewer children, they delay the onset of reproduction, and they have less children in general because of increased choices in education for family planning. Now, there are some also other things in general when there's cultural acceptance of family planning, or if there is wide access to birth control or other family planning kind of things, that's going to decrease the amount of children and also increase the confidence that children will survive to adulthood. So people do not feel pressured to have as many. Now, again, you could look back in those tables that I presented to you earlier today, and any of those reasons would be acceptable here. You just have to remember to do both of what the question is asking you to do. Identify, but then also explain. All right, guys, that is it for week 9. I hope that helped you out a little bit, and good luck.